Alright guys, in previous videos you learned about stoichiometry, which is basically calculations with reactions. That's all it really is. I have a starting amount of certain substances and how much can I expect to make. The everyday application of this is if I owned a bakery, for example. A bakery is nothing but a chemical reaction all the time when you cook things. So let's say I'm making cakes. When I go in and I'm going to make cakes, what I'm going to end up doing is I'm going to end up buying my reactants, which are going to be sugar and flour and butter and all that kind of stuff. And when I cook the cakes, I should know how many cakes I'm going to make because that's my profit. I don't want to spend too much money on these things so that I can make enough profit here that I can pay my workers, pay the light bill, pay everything else. So I've got to pay a certain amount and know how much reactants I need, how much of the raw materials, and how much I'm going to make. And so we're learning how to do these calculations. Today we're going to look at that stoichiometry by what is called a limiting reactant and excess. So you need to watch very carefully as we go along and do this, okay? So just quick reminder of what we already learned. With stoichiometry, we know that these numbers are already in a unit. They're all in moles. The word mole is not going to be written. I'm just going to write it in just as a reminder. So basically, 2 moles of this with 3 moles of this is going to make 1 mole of this and 5 moles of this. Very logical. Okay, so if I'm talking my cake recipe and it takes 2 of this with 3 of this to make these things, the question really becomes, what if I want to double the recipe? Well, that's easy. Then I double the numbers, I'll get double of what I have. And that's really all stoichiometry is. It's calculations with a known reaction. So let me ask you a question real quick. If you had 4 moles of this, now I'm going to put a box around it because I'm going to write in a bunch of numbers. That's just my start place. That's why I'm boxing it in just for right here on this video. If I had 4 moles of this, what are all the other numbers that are going to happen? Well, in reality, I can tell that's double. So I already know this is going to be 6 and this is going to be 2 and this is going to be 10. That's really easy. All in what units? Moles. Super easy. Okay? What if that number is not 4? What if that number is 7? All right? Well, real quick, 2 to here. Well, 7 divided by 2 is a change of 3.5. So if this changed by 3.5, then everything's going to change by 3.5. So if I take that 3.5, I'll just grab my calculator so you can see it, times 3, that means that answer is 10.5 moles. That 3.5 times 1 is going to be 3.5 moles. And that 3.5 times 5, and again, I'm just showing you the numbers on the screen so that you can see it, is 17.5. It doesn't matter how weird the numbers are, how big the numbers. I mean, if this number was 70, then 70 divided by 2 is a change of 35. Well, that's going to apply to everybody in the whole reaction because if this one changes by that much, they all change by that much. So 35 times 3 is going to be 105. 35 times 1 is going to be a 35. And 35 times 5 is going to be 175. So I already know the values for everything. So they can be really big numbers or they could be really, really small numbers. Let's say it's 0.015. That's fine. 0.015. Then what I'm going to do is I'm going to take 0.015 and I'm going to divide it by 2 because it's supposed to be a 2 for the reaction. So what do I get? 0.0075. So there it is. There's my change factor. So that means all of these are going to change by that much. So all I do is 0.0075 times 3, and that answer is 0.0225 moles. Okay? 0.00075 times 1 is 0.0075 moles of this. 0.0075 times 5, and I can get that answer too. It's very, very simple. Okay? Now, what happens if I have this? Because in reality, when I'm making cakes, for example, I don't just have one thing. I'm going to have more than one thing. So watch this. Let's say if I had 4 moles of this. So I'm going to deal with what is called limiting reactant and excess. I have 4 moles of this, and I have 6 moles of this. What is this one doing? 4 divided by 2 is a change of 2. 6 divided by 3 is a change of 2. That's an exact match. They're both changing by the same amount, so that means that's 2 and that's 10. But let's say when I pour out of the container, because we know that weird things happen, like when you buy hot dogs, there's more hot dogs in the package than there are hot dog buns. And so you always have more hot dogs than you have hot dog buns. So what if your numbers aren't exact? So let's say that this was a 7, okay? So I have 4 of this and 7 of that. Well, 4 divided by 2 is a change factor of 2. 7 divided by 3, just so everybody can see the number, is 2.3 repeating. Now I have a problem. This one's changing by 2, this is changing by 3. Now, what's happening is one of these is going to run out before the others. And so I'm going to show you a quick example just using pins because it's the easiest way I can do it on the screen. I'm going to take pin caps and pins, and so I'm going to do a just fake reaction here for a minute. It's going to take me a second. Perfect. Let's say this is what I have. I'm going to react these with these, and I'm going to make something. So here's how the reaction happens. I take one of these, and I just made something. Isn't that what a chemical reaction is? All right, reaction goes. There's one. I made that one. There's another one. I made that one. Here's another one. Oh, if I can pick it up. And there's that one. And then I have this one. And got it. And, uh-oh, I have a problem. Why? I ran out of something. I still have some of these, but I don't have something to react with it. So the reaction's done, right? If I don't have anything to react with, it's over. Something is limiting, see that word right there? Limiting, but I also have excess of something. So the excess is that pin cap, okay? So what happens is the reaction stops. Why? I don't have enough of something. If I were to pour something back in, like, oops, I poured in some more, then the reaction can go again. Okay, but I didn't have that. Okay, so there's something that limits how much I can take. What limits? As soon as something runs out, it limits what you can do. Excess is the thing you have extra of. So let's use the example that we see right here. 4 divided by 2 is a factor of 2. 7 divided by 3 was a factor of 2.3. Which one runs out first? Let me tell you this, it's not about these numbers. You're not looking at 7 and 4. What you're looking at is your change factor. If I'm correct, that one runs out first. This is the one that I have excess of. So this limits what I can do. So here's what I'm going to do in this reaction to calculate. As soon as which one runs out, it's over. That one. As soon as this one runs out, it's over. So I'm just going to ignore this number for a minute. If 4 divided by 2 is going to run out, when it runs out and the reaction stops, how much of this over here did I make? Well, I made 2 moles of this, and this times 5 is 10 moles. Since this is excess, okay, so let me say it different. I have 4 moles of this, and I have 17 moles of this. Okay, let's see what happens. 4 divided by 2 is a change of 2. 17, and I'm just showing you all the numbers on the screen so everybody knows, 17 divided by 3 is 5.67. All right. Who do I have extra of? 17 because it's a bigger number. No, 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 no. Look at your change factor. It was supposed to be a 3, and it's now, wow, it's a whole lot more. Since that change factor is so much, this limits, this is my excess. Now notice the abbreviation I'm going to use. This is what my professor did in college, excess. So he said, here's how you do it real easy. He would just write an X and an S over the top of it. So you can still see the number, but since that's excess, this is not part of the calculation. I use this number to calculate all my values. So 4 divided by 2 is a change of 2. So when this runs out, I have 2 moles of this and 5 moles of this. But what if the numbers are closer? Watch this one. See if I can get this one to work. Let's say I have 8 moles of this. Oops, these numbers are going to go away. 8 moles of this and 6 moles of this. Okay? So watch this. 8 divided by 4, 2 is a change of 4. Excuse me. 8 divided by 2 is a change of 4. 6 divided by 2 is a change of 2. Do you see it? This guy's going to run out first. So this is my excess. That's my excess. Okay? All right, and so then 6 divided by 3 is a multiplier of 2 times that, I got it. But what if this number would have been a 6 moles? Ooh, they're the same. Or better than that, let's use 5. 6 divided by 3 is a multiplier of 2. 5 divided by 2 is 2.5. This is a great example. So watch this. A lot of people look at this and go, oh, this is my excess because 6 is bigger than 5. That's not what we're looking at. We're looking at how much did it change. 6 divided by 3 is a change of 2. 5 divided by 2 is a change of 2.5. This is my excess. So I use this number to calculate everything. All right? So catch the words. Excess is the thing I have too much of. Limiting reactant is the guy that limits how much you can really make. When this runs out, it limits it. Now, I bet you're getting it. You'll get to practice quite a few of these. But let me ask you this. All right, be ready. Trick question. It's not a trick because I bet you can do it. What happens if I had 50 grams of this and 50 grams of this? How do I know who's excess and who's limiting? The answer is I don't know right now. Why? Wrong unit. Wrong unit. Because I cannot compare grams to moles, but I can take 50 grams, change it to moles and get an answer. I can change this 50 grams. Okay, so I would use the real compound here to change this, and you've already learned how to calculate grams to moles. Calculate grams to moles, and let's say we get 1.65 moles. I'm just making these numbers up. And I change this one and I get 4.63 moles. Now can I tell limiting reactant and excess? Yes, I can. Because 1.65 divided by 2, I'm going to show you the answers. And again, these are made up numbers, but my point is this: you cannot use grams. You had to change it to moles. So 1.65 divided by 2 equals 0.825 moles. There's my change right there. Okay, 0.825. 4.63 divided by 3 equals 1.54. So I immediately know this is my excess. Why? Because that number is bigger than that one. So I'm going to use that number to calculate everybody over here. So if this is 0.825 times 1, so this would be 0.825, what units? Moles, because everything's in moles. You can only work the problems in moles. 0.825 times 5, 0.825 times 5 is 4.125. 4.125, great, moles. What if the question didn't want moles, they wanted grams? Then all you do is you take your railroad track that you've been learning, take your moles to grams and get your answer here. Boom, there's your answer in grams. And you've already done this skill before. All we're doing is using this skill within reactions. The skill is stoichiometry, limiting reactant and excess. The real question, catch this and I'm done. How do I know if I have to worry about limiting reactant and excess? Here it is. Here's my reaction. If my question gives me 4 moles, there's my start point. If they give me one number, it has nothing to do with this and this, because it doesn't matter who runs out. I only have one thing to work with. If they give me 2 numbers, there's my 2 start numbers. This is when I have to worry about limiting reactant and excess. Figure out who runs out first. Whoever the excess is, mark them out and use the other one to calculate your values. Not a very difficult skill. You can do this.